Hi, everyone. I'm Sajanya Gumajela, Capricorn Power's Communication Manager. Thanks for joining us for this last-minute webinar. We really appreciate your support throughout our equity crowdfunding campaign. Firstly, I'd like to thank all of our early investors for coming in. We're already past our minimum funding target with over 200,000 invested, and we welcome more than 120 new shareholders to the company. We thought we'd take some time out to answer some of the questions you might have about our innovative Cleantech and explain our integrated bioenergy power station in a bit more detail. To help with that, we have our CEO, Mike Hodgkinson, and our head of products, Shaun Scallan. Mike has a background in finance and energy. At Citigroup, he successfully launched a trade finance startup that now settles over $30 billion per annum. He has worked in the energy sector for almost 20 years, completing utility-scale renewable energy projects. And he has an executive MBA from Columbia and London Business Schools. And Shaun has a background in electrical engineering, chemical engineering, and process control, and a master's in renewable energy and experience in utilities and paper manufacturing. He is also on the advisory board for the ANZ Biochar Industry Group. Hi, Mike. Hi, Shaun. How are you? Thanks for joining.
Hi, Sajana. Hi, Mike.
Great. So just a bit of housekeeping. We will have a Q&A in case anyone does have any questions for us. Feel free to write your answers in the chat. And don't worry if we don't have time. We will post written responses to any of our questions on our virtual activity newsfeed. We're also recording this session in case you want to rewatch it later. So we might as well jump in. And the first question is for Mike. Mike, can you explain what a heat engine is and how heat engines convert thermal energy into electricity? And is it true that the Barton engine can use different sources of thermal energy? What could these energy sources be in addition to biomass?
Probably knows by now, waste heat is the world's most abundant source of energy. And a large part of this waste heat comes from inefficient heat engines. There are many types of heat engines, but what they all have in common is that they turn energy from heat into mechanical force. So an example is a steam engine, like the one at our local Puffing Billy. Puffing Billy burns coal to create heat that turns water into steam, and the force produced by the steam pressure pushes a piston. Our heat engine doesn't use any water. We use air instead, and our piston moves a magnet around a coil, which of course generates electricity. So we can use heat from many different places. We just want it to be high temperature because the higher the temperature, the higher the efficiency and the lower the cost of the electricity. Just some examples of some applications include all forms of waste to energy, gas flares from a landfill or a wastewater treatment site, concentrating solar, the exhaust from gas or diesel engines, and many others. So the future is full of opportunity for the Barton engine.
And why is Capricorn's heat engine up to 3 times more efficient at converting heat to electricity at high temperatures?
Sure. So in simple terms, our heat engine is able to take full advantage of the efficiency inherent in the higher temperatures, and our competitors are not. So high efficiency at small scale means more electricity from the same waste heat. Small projects tend to have high fixed costs, and so they need to spread these costs amongst as many kilowatt hours as possible to keep the average cost of electricity low. So that's our advantage. So what that all means is that our heat engine will enable many small scale electricity projects that weren't previously commercially viable. And solar PV has shown that demand for on-site power generation is quite large. You could say that our heat engine is just like a solar PV for business. because we generate electricity at less than 0.5% of the footprint per kilowatt hour of solar PV. And that, of course, makes us more suitable for many businesses.
And so, Mike, why did Capricorn focus on bioenergy? What other third parties are involved to create an integrated turnkey bioenergy power solution?
So we've always, of course, been exploring the best way to monetize our heat engine innovation and our team's capability, because, of course, a great product is necessary, but not sufficient to create a great business. So fortunately for us, waste is presently a serious and urgent problem in Australia. And we've always known that char maker heat source, which has a temperature of about 800 degrees Celsius, is extremely well suited as a waste heat source for our heat engine. So this year we had a commercial breakthrough, 3 commercial breakthroughs, you could say, because we had 3 customers independently agree to pay us for feasibility studies for waste to energy projects. And it is, of course, a good sign for our product when a customer's problem is so serious that they're prepared to pay to help us solve it for them. One of these projects is yet to begin because of COVID-19, but the other 2 we've now almost finished the feasibility studies for. The first is a signed MOU with an ASX company who we believe will make an excellent bioenergy partner because they have a great deal of woody waste around their sites globally. The second, we're being paid, again, I can't say who, I should mention because of confidentiality agreements, but we're being paid to develop a project that utilises processed green waste from the city of Greater Geelong. And that's significant because selling all of that biochar that we produce from this project would enable us to achieve positive operational cash flow, potentially as early as the end of next year, which of course is great for shareholders. And the good news is that we already have a letter of intent for 25% of the biochar from that project already. So, you know, finally, the good thing about these projects is, of course, we're using proven, experienced vendors for this pyrolysis equipment and material handling.
And the next question actually is for Shaun. So Mike mentioned our 3 feasibility studies. Can you discuss each one in detail?
Sure, thanks, Sajanya. Well, the first feasibility study we're doing is to determine if we can use currently wasted byproducts of wood chip processing to generate electricity, heat and biochar. And the benefits of this to the business include energy cost savings and income from the biochar, giving 2 savings or 2 income streams to build the business case. The second is to assess the feasibility of creating biochar from oversized material from a council composting facility. And this stuff is normally destined for landfill. So it's a good way of using that resource, which otherwise is wasted. The third feasibility study, which is on hold currently, is looking at council green waste to provide, again, heat, electricity and biochar. It's a common theme here with pyrolysis being the mechanism by which we extract heat from the biomass and create the biochar. So the biochar could go back into councils' parks and gardens, for example, and enhancing the health of the soil and the ecosystems locally as one benefit.
That's great. So Capricorn's bioenergy solution suits councils and timber processors. Can you outline the bioenergy potential from biomass in Australia?
Yes, certainly. The bioenergy can be produced from any biomass. So biomass includes things like agricultural residues from crops and forestry. Green household waste is another example, paper and cardboard, and also food waste. So there's a number of sources of waste, if you like. I don't like using the term waste. They're just resources we haven't found out how to use properly yet. So that's our approach. And so about 6.7 million tonnes of organic waste is sent to landfill in 2016-17. And that sits in landfill and creates methane. And some numbers put it at about 55% of that is methane, from some stats that I'm aware of. So that's the landfill story. The residues from forestry are also a viable source of bioenergy, and the projections that have been done out to 2050 is there could be as much as 5.6 million tonnes of forestry residue available. That's quite a bit, and so can generate quite a lot of electricity from that and heat for process usage as well. And then the biochar is available for various applications. And so these numbers are dwarfed by agricultural residues in Australia. In WA alone, they have 10 million tonnes of waste biomass every year. And so that, coupled with councils across Australia that have vast quantities of green waste that not all can be used and ends up in landfill, shows you the potential scale of the biomass sources that we have. So we really think, and many people think this, so we're not alone, is that it's a real sleeper, because bioenergy from biomass is renewable by definition. And so in Australia, about 1% of electricity is generated by biomass, and that's about 11% of renewable generation in Australia. And some predictions and calculations have been made that say we could end up with 20 to 30% of Australia's electricity produced from biomass by 2050. So it's got a lot of potential.
Yeah, and can you discuss the biochar market and what is the product used for and who buys it?
Yeah, well, this is a big topic because biochars ain't biochars. They are they're made based on certain feedstocks will provide certain quality output, which is used or can be used in certain applications. But simply put, it's charcoal that comes from biomass, so biocharcoal or biochar for short. So that's where the name comes from. And it can be used in a range of applications, from improving soil productivity and ecosystem health, so putting it in the soil, and through to water filtration and high quality stock feed additives to help with the health of grazing animals. And it also has the side benefit of reducing their methane emissions, which is kind of a nice way of doing it. The other thing to say is that the soil carbon that exists in Australia has been depleted over the last 200 years, and to the point where it's about half of what it was before white settlement. And so the job is to restore that. And once you put soil carbon back, so in the form of biochar, it stays there for many thousands of years. So it's a real example of carbon capture and storage.
Yep. So bioenergy is a larger part of the European energy solution than in Australia. Why is this? And do you think there are opportunities for bioenergy to grow in Australia?
Yeah, obviously I do. And I have a bit of a theory about why we haven't done more in Australia. And I think it's down to our historically low energy prices. So the motivation hasn't been there to do much about it. So if you take increasing power prices and increasing waste disposal costs as landfill levies increase, is that we've got a perfect storm for justifying the application of technology that takes biomass and turns it into electricity and heat and biochar. So I think we can see that there's a bright future in terms of the biomass that's available and then the energy that could be produced and other benefits from it. So I think it's a fantastic opportunity.
Yeah, absolutely. So the last question that we have is from Mike. Outside of bioenergy, are there any other markets where the heat engine can be deployed?
Yes, of course. I mentioned some applications above, but also I wanted to mention in the waste to energy space, we have a situation here in Victoria, as Shaun has mentioned, where the landfill levy is doubling over the next few years to over $126 a tonne, which is just below the nationally leading level in New South Wales. And that's driving a great deal of interest in small scale on-site waste to energy systems, producing waste heat at about 1,000 degrees or even higher in this case, which again is a great temperature for Capricorn Power's heat engine. So I should mention these opportunities are consistent with the waste pyramid, because this is sort of on-site, typically C&I waste that's going to landfill. So we've got a letter of intent from a company called Vortex, who make one of these systems, and we've been approached just recently by someone else with a similar system. And I think that this is a very promising area commercially for our heat engine, because these on-site systems suit a 100 kilowatt product, which is not too big for us for where we are now. Initially, they're local projects, and initially we can focus on customers that have very high energy bills, and those are the good first customers to focus on. So I think that as well as bioenergy, there's also a huge opportunity for us in these other waste to energy markets, and we'll demonstrate that next year.
Great. So we might move on to the Q&A. We have a few questions that have come in. The first is the energy source sustainable?
Who wants to take that? Okay, look, it is, because it comes from stuff that's grown, and you use the waste, and then it's regrown. So it's renewable by definition. So yes.
Great. And second question, in layman's terms, what is the process for burning the biomass to turn it into heat and char, and how come there are no smoke or carbon issues?
Do you want me to take that again? The pyrolysis process we use heats the biomass effectively, and what comes off the biomass is a thing called syngas, which is burnt in a separate part of the process to provide heat back, to be a self-sustaining process, but you have net heat left, and that net heat is what goes through our heat engine. And so the combustion is controlled, and it's controlled in a way to meet local EPA or regulatory guidelines. So that's built into the process. So from an emissions perspective, and the heat we just take forward and we convert into electricity through our heat engine. But we can also use the heat to dry the biomass as well, lifting the overall percentage efficiency of the process. Hope that answers the question.
Yeah, and then I think this one is for Mike. Could we talk a bit about how we've arrived at the evaluation of the company?
Yeah, sure. So valuing early stage companies is extremely difficult, is the answer. We have a very experienced board of directors and very experienced executive team. And what we've done is use our experience, particularly with reference to other early stage companies. We've sort of made a recommendation about what we believe the equivalent valuation is, and we put that to shareholders, and that was approved. That the sort of examples we've sort of looked at in terms of comparable companies would be a company like Blue Glass, for example, was a pre-revenue company. They raised $6 million back in 2006 at a $28 million valuation when they went to IPO. They're currently worth about $42 million. Another comparable company that we're closer to the valuation of is Clearview PV. They were a pre-revenue company that raised about $5 million at a valuation of about $19 million. And they harvest light from windows to generate electricity. So yeah, comparables is usually the main sort of way we value the company.
Great. So we might try to keep this short and sweet. Let me just see if there are any more questions that we want to take. So one last question, I think. I think this is one's to Mike as well. Can you franchise the technology for international use to expand the cash flow of the company quicker?
Yes, franchise or licensing is definitely something we'll be sort of considering in more detail early next year. It's too early for us to be sort of creating a detailed strategy on that at the moment, although we have been approached by a few interested parties overseas. But our plan would be to develop that strategy more fully next year, early next year.
Great. And I think we can take one more question. So emissions seem to be such a hot topic these days. Is this as important as efficiency, or are they the same thing?
So yes, efficiency is very different from emissions.
Yes. That's true. Do you want me to take that, Mike, or you can have it?
Sure, sorry. Yep.
Okay, so yes, efficiency, or Mike could speak on this too, so either of us. Efficiency is really the conversion of the input energy you have to output, so therefore not losing as much as you do with some of the competitive technologies that we're competing against. Emissions are about, in terms of if you're talking about reduction of emissions, we generate renewable energy, so that will offset the emissions from fossil fuel generated power. So, from that perspective, if you're talking about the emissions of the process, well, I think I mentioned earlier, they're controlled fairly tightly to the requirements of various environmental protections organisations or planning, local planning guidelines. So yes, they are different things. They are a bit related, but they are certainly separate. Do you want to add anything to that, Mike?
Yeah, look, just the carbon emission point that you made earlier, which is that with the right type of biomass feedstock, what we're actually doing is carbon sequestration. So it's a negative emission technology or product that we're sort of rolling out as well with those applications.
Yeah, I'm glad you remembered to say that. So negative emissions technology, and if you were to round this out, it's a circular economy thing in action, taking resources and recycling them through some productive cycle so that you're not wasting anything. So there's no waste in nature, as we all know. So we're trying to work towards that as the ideal with our processes. That's fair to say, isn't it, Mike?
Mm-hmm.
Great. In the spirit of keeping this short and sweet, I think we might cut it off there, but don't worry, we will provide responses to all the other questions, and we'll put them in the virtual activity newsfeed. Thanks again to everyone for joining us. We really appreciate it. As you know, our investment is now live to the public, which is really exciting. Feel free to email us at info@capricornpower.com.au as well. And as always, consider the offer document and CSF risk warning before investing. Thanks again for your continued support and for sharing our vision of a more sustainable future. Have a great night, everyone. Thanks, Mike. Thanks, Shaun.
Good night.
Thanks, everyone.
See you, Mike.